So, for those of you who were watching the, what was it, 2-3 weeks ago, I was doing the, that's what I'm looking for, garage door opener. We were taking a look at the garage door opener that came with my house and trying to see if we could find any interesting bugs in it. The problem is that after spending, I guess it was about 4 hours on stream looking at it, and then another 2-ish off stream while I was able to actually, go in, press the buttons, talk to it directly. Turns out that garage door opener, if you don't press a button on it, it looks like it shuts off all the dynamic services. And what do you do? Like, I can't do anything if there's nothing going on. Turns out, after I kind of decided that I was done with it for the time being, turns out that there is a Marvel sock bug that somebody published recently that it's probably vulnerable to, but that's going to be really complicated to try and land, and it's I don't think it's necessarily in my best interest to try and land it right now. So, where that leaves us is today. And today, we're taking a look at VirtualBox. So, VirtualBox is a virtualization platform. You might be familiar with it. As far as I'm aware, it's the only it's not the only, it's one of the more popular open source virtualization platforms out there. Because kind of when I think of the major virtualization platforms, I think of VirtualBox, VMware, QEMU, Hyper-V, I guess KVM. I think those are the big ones that I think of. Just checking to make sure that you can actually still hear me. But right, so those are the 4 major virtualization platforms that I think of. VirtualBox is the only of those that is open source, well, except for QEMU, and free, except for QEMU and Hyper-V. Okay, this whole argument doesn't work out well. But VirtualBox is one of the more popular ones. It gets used a lot because it runs well on Windows, and it's old, like there's a lot of history working with it. There's my understanding is it gets used a lot for automated analysis. I don't know if it's for any good reasons or not, but it's relatively popular. And the reason we're looking at it in particular is because in 2-month and a half time frame, we can actually pull this up here to Pwn to Own is happening. Where is it? And turns out they're going to have VirtualBox as one of the targets. Where is it in here? Yep, VirtualBox is going to be one of the included targets. Now, personally, I don't expect to be collecting on that. And I also don't expect to get on stream any bugs found. My intention here is that we're going to do all of the starting research. We're going to learn what does a VirtualBox exploitable vulnerability look like by going through some CVEs. That's going to be the first couple things we do this stream. Here, let me see if I can get this set up properly. Come on, grab here. We want you. Sorry, I'm trying to line these up properly. Can I zoom in more? Oh, there we go. We want you over here like this, and then you cut. You're like that, and I want you like that. There we go. Okay. So, what we're doing here is we're going to take a look at some of the CVEs that are currently public for VirtualBox. And that's going to be a good idea because it's going to tell us what other public vulnerabilities look like, things that other people have found. What did they find? Where did they find it? And what exactly does it look like? And some of the reasons that's important is, let's say we're looking at a target, and I'm trying to think of a good example here. So with something like VirtualBox, the idea of a guest to host escape is kind of broad. If I can write an arbitrary file from a guest onto anywhere on the host file system, that's actually really interesting. And it's something that might not necessarily be obvious if you haven't spent a lot of time thinking about it. So what we're going to do is we're going to go through all of these different CVEs that people have found. After we've done that, we're going to get a build environment set up. That should be... basically, we need an environment to work in. Well, actually, let's change that. Get an environment set up. That is a build environment. It is also a debugging environment. And I know talking with NiklasB about this, it sounds like we probably won't be getting the build environment right away. At least talking to him, he's previously done some research into VirtualBox, and turns out getting that build environment is a non-trivial situation. So we'll see exactly where we end up with that. At the very least, we need something we can debug, because once we've done all that, we're going to test some CVEs. So once we've identified what an exploitable bug looks like, and we have a test environment set up, we're going to actually take some of those, and we're going to throw them against the system. Git crashes. And then we're also going to write at least one exploit. And the reason for this is, like I was saying at the beginning here, if we don't know... So, sorry, I need to get my thoughts a little bit in more order. How to actually exploit different systems depends wildly on the target. Good examples are things like if the application you're looking at has a custom allocator, how you exploit something on it can vary drastically compared to something that's using just the built-in allocator off your system. Similarly, some targets have really easy mechanisms that you can just jump to, and you're going to get all sorts of interesting things. Maybe there are well-known places we can write into memory that are going to get things executed. There's all sorts of tricks like this that can come up, and getting a good idea of what those look like before we start looking for new bugs is a good idea, because it helps inform us what we're looking for. A great example of that is on some targets, you don't ever need any sort of information disclosure. And by information disclosure, I mean something like learning what is at different memory addresses in the application, because for some reason or other, that's essentially free. Maybe there's interesting things at static locations. Maybe the application doesn't randomize anything. Maybe there's some very easy way to get a pointer. And so we don't care about looking for those types of reads in the system. On other cases, if we need an ASLR defeat, well, we're going to have to figure out how to do that. And that might be a separate bug from, an arbitrary write or something like that we're going to have to learn before we can do anything useful. So this is the rough outline of what we're going to be doing. I don't expect to get through all of this today. I definitely don't expect to get all the way to writing exploits. I actually expect we're going to spend most of today going through these CVEs. And the reason for that is because if you take a look at the list of CVEs, VirtualBox has had quite a few. We're up to 27 so far for the year, although it looks like they were all published on the same day, so it's probably a batch thing. But still, we have 27 vulnerabilities just for 2019 to go through. And then 2018 takes us all the way to 2018. We have 69 vulnerabilities in total to go through. If we're just doing the past 2 years worth of vulns. And I think that's a pretty reasonable idea. Things from 2018 on should be reasonably close to what the current code base looks like. And it's going to give us a good idea of what we're looking at. If we go too far back, we're going to be looking at bugs in parts of the code that might not even exist anymore. And if we don't go back far enough, we won't have quite as good of an idea of the different types of bugs people are finding. But in any case, that's where we're going to be at. Oh, there's one more thing that I want to get in here, which is Metasploit module. Write a Metasploit module. So it turns out, while I was doing some of the research here, there's nothing in VirtualBox, or there's nothing in Metasploit right now that has a Metasploit module for it. They've got 2 in there that I can find, and that's it. And that's really surprising to me. It seems like the kind of thing that I would kind of expect, maybe not to have the most recent things, but they require VirtualBox 3 for anything in Metasploit to work. And I kind of assume it'd be the kind of thing that'd be kept up to date-ish, especially with so many public bugs, and the fact that it's been one of the pwn2own targets every year. So there's new public bugs coming out every year for this that are relatively regular. I'm relatively surprised that there's not another one. So I think the end of this series is going to be, let's commit some code back that gives us a way to look at that. So going back to the chat here, Yoshi mentions trying to put together a YouTube downloader. Potentially. We'll see where things end up. I think this series is going to take quite a while to get through. And then for Serial Back, please help me to find a good way to be good at reversing. I mean, the best thing to do is to practice things. There's a lot of very good resources out there for war games, CTFs, things like that. They're a good place to start to learn, get comfortable looking at a binary, trying to reverse it, trying to look at what it is. There's also a very good case to sit down, write code yourself, and then disassemble it and see what that looks like, and go back and forth. And that can really help understand exactly what's going on in programs better than just reversing on its own can. And then Niklas says that I should ignore all the 3D bugs. We'll see. At the very least, I want to take a look at a couple of them for us to have a good idea of what those look like. I assume that that's because they're going to end up being difficult to exploit or hard to trigger or something like that. But we'll see. Okay, so I guess jumping into this, let's start with this here. So I'm not sure exactly how I'm going to handle this to-do list. One of the things that I decided I was going to try and do with this stream going and hopefully going forward, assuming it works out, is try and get a little bit better of an idea of where we're at by having, yes, I can zoom in the web browser, having some details over here on the side with where exactly we're at. So right now we're taking a look at the CVE 2019-2556 and good. We have very little information about it. What do we have? So it looks like they reported a whole bunch of vulns all at the same time. That is absolutely infuriating that this list is not ordered. We have 2500, 22, 2524, 2552, 2520. Like, I don't understand how this is ordered at all. It probably is revealing a little bit of the areas of the code that these are in. If these were all reported at the same time, and the ordering here probably indicates that, like, these 3 bugs might have been reported by the same person. These are maybe these are not only by the same person, they came at the same time and are probably related. And then here we're jumping back. I don't know that for sure, but I can make some guesses. Wow, there's a lot of chat today. So int 80, the talk about exploiting chakra, was that Ned Williamson's talk? I believe he gave one at CCC related to that. As far as you're a master's student working on cybersecurity, looking for a job, it depends on exactly what you want to do. There's a lot of openings throughout the industry for various different specific things. Your best bet is to try and find something you enjoy doing, focus on that, and learn it well. And unfortunately, just plaster interviews everywhere. There's a lot to be said for interviewing a lot. Having good interview skills is a skill, and it's something you need to practice. So I can't necessarily help. One thing to do is if you have examples of things you've worked on, it makes it a lot easier to interview. Being able to come into a job interview and say, here's a project I've been working on, gives you a great thing to talk about for your interview. You're able to talk about that. The person interviewing you gets a good idea of where your skills are at. And in general, you're more relaxed when you're talking about things that you did, as opposed to the interviewer going, okay, tell me about this thing. Tell me about this thing. And being able to have that background really helps. Jonathan Jacoby was the one whose talk it was. I don't think I've seen that one, but I assume, I think going through things in this approach is relatively standard when you're looking at a brand new target when there are public bugs available, especially for harder targets. Being able to start with what other people have done just makes everything else easier. Okay, so conveniently here, jumping back into this now, it looks like all of these bugs were through ZDI stuff, which is probably related to Pondone or something else. But do we have any details? We have no details. The only details we have here, and what I was a little bit concerned that we may have to end up looking at, is we have vulnerable, not vulnerable versions. So we know that all of these CVEs, and we're going to have to copy this list into the to-do in a minute, were vulnerable in 5.2.20, but they were not vulnerable in 5.2.24. So we can take a diff of those two sets of source code because, like Fabio mentioned, VirtualBox is open source. We can take a look at the 5.2.20 source code and the 5.2.24 source code and look at the diffs. And we won't necessarily line up with exactly which ones are these CVEs as opposed to other things. And there's going to be a lot of additional features, but it'll give us a little bit of an idea, I hope. And hopefully we're going to be lucky and there's like comments in there. Like it'd be great if there are some commits in there that say things like fixing CV 2019-2500. But unfortunately, this report for it is less than useful in terms of knowing what any of them actually are. And we also had the Oracle note about it. So the Oracle Critical Patch Update Advisory. This tells me less than nothing? Is that correct? Thanks. Great. Well, conveniently, we know that at least 3 of them, there is someone in chat who knows exactly what they were. So we have a little bit of a hit there, because if we come back over here, 2019, 2446, 2448, and 2522 are all ones that Niklas worked on. So that's good. There's a list at the bottom. I don't see a list. I'm not sure at the bottom of where I should be looking. Oh, here. Oh, here. Here is actually something useful. Okay. Where are we at? Oracle Construction, e-business, Enterprise Manager. These are links, aren't they? Yeah, these are links. VirtualBox. Here we go. Well, these are a little useful, but they're not ideal. It doesn't actually tell us what any of these are. It tells us that here are the CVEs that they fixed in VirtualBox. There's scores related to them, which tells us almost nothing. We have version numbers, which, again, tells us almost nothing. This is interesting. So we have things like this. That prior to 5.2.22, but not mentioning 6.0.02, and they're not going to have... So it means that this one, 2018-3309, is something that was probably removed in the 6.0 branch. So it looks like what we're probably going to end up doing here is we're just going to have to pull down the source and start looking at it, because someplace between the 5.2.20 tag and the 5.2.24 tag are going to be useful. Are those 22? Do we have a 5.2.23? That'd be useful. 5.2.23. No, 2.2. Well, it's still good. I assume even numbers are stable releases, odd numbers are testing or edge or whatever VirtualBox calls it. So one thing that I'm not thrilled about is that the SVN is pretty much out of sync with the actual releases. So one of the things that I'm not looking forward to here is that VirtualBox uses SVN for their source code, and it has been a long time since I have used SVN. Where did we go? Okay, so we already have one of these open, don't we? So, do I even have SVN installed? I don't. Sudo apt-get install subversion. Oh, hey, I remembered it. That's always the kind of nerve-wracking thing. So I was traveling and away from this computer for about 2 weeks, and coming back, sitting down and going, and the first time you look at that password prompt and have to go, shit, what's my password? It's always just a little bit nerve-wracking. Trying to go, did I forget it this time? Or was it burned into my brain properly? And it turns out this time I was lucky. To be honest, this is an older password that I've used for a while. It's just that this is the only place that I'm currently using it. It's actually been the password to a bunch of my CTF boxes for a while. So having a SVN to GitHub. Interesting. What is this? SVN to GitHub VirtualBox. Interesting. Are these at all useful? Where do they go here? Where's commits? Ooh, this is not bad to work with. Look at that. Okay, I can work with this. Oh man, these are actually relatively easy to go through. Okay, you know what? We are also going to pull this down because that's going to make it very easy. Thank you. No, this is from before the CPU. I don't know what that means. Okay. So this has been closed, but it looks like they're still getting updates. So this will be good. So let's watch this finish. So right now we're pulling down the SVN source code. And of course it's slow because VirtualBox is actually a very large piece of software. As we watch some of this go by, part of the reason it's so large is because they emulate a whole bunch of different devices. We end up having all sorts of... That is correct. If the latest patch was January 17th, and today is, and they haven't had an update in 21 days, then they do not have the latest round. That is correct, yes. So unfortunately, we are learning how to SVN today. Okay. So, adding to this list, learn things. That's the one I want. Learn to SVN. Okay, let's go do this while this is downloading. How the crap do I SVN? How the shit do I SVN? Nope. So I know there are, how do I get a largely distributed binary VirtualBox? So VirtualBox will put out releases, which I assume are pretty close to it. And we can go through here and get like, here are the older builds. I would assume we probably want to aim at, like we can get them this way. There's a whole bunch of different options, but that's the way we would get, we're going to end up getting the releases when we need them. Come on. Quick start. Here we go. So what's a repository? Because SVN does things a little bit differently, doesn't it? Blah, 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 blah. Adding stuff. Setting up a local repository. I don't want to do that. I want to, like... It's been so long since I've used SVN. So I copied it. We're pulling it all out, and I can SVN log, which I guess does kind of useful things. So I SVN log, which tells me things happened. So you should be able to do SVN log, and from SVN log, I'll be able to hopefully get messages related to some of these things getting patched. After modification, array.c will look like this. Download the source tarball. Is that going to be significantly faster and still get me the history? I suspect the reason it's taking so long is because we're pulling everything out. Although that looks like tar output anyway, so it's possible that that's using it under the hood. I want to... Okay, you know what I want? I want an SVN cheat sheet. cheat sheet. Oh, no, I want, come on, that one. I want the opposite of those things. Okay, well, okay, what does this tell me? So I update, I can check out and do that. Get a working copy. So we're currently checking it out and getting the working copy. I can SVN log to find out what the log looks like. How do I go back to a version? Copy, rename, delete. Revert. How do I go back? Can I not do that in SVN? Well, that seems wrong. So that'll revert. It's fine. I can do a log, that's fine. I can blame, that's not super useful, but fine. I can diff. Diff is going to be useful because I should be able to yes, I want to SVN diff to get what I want. Awesome. So does the tarball come with what we need? Sources. It's 150 megs of source compressed. Jeez. Thanks. I guess that also probably includes all their documentation and stuff like that, so I can't complain too much. Well, they're using we're using SVN because they're using SVN, and if we're going to go through their source code, we're going to have to use whatever they're using. So 150 megs is down. Go ahead and finish your little check. Come on, go ahead and finish. Come on, Chrome. You can finish this. Oh, is Chrome trying to inspect inside of it and make sure it's not malicious? Of course it is. There's also tarballs for every release. Ooh. Maybe that's what I should be doing here. Yeah, that is the smart decision here. So the January 15 one is the most recent one, which tells us where we're at. Thank you, Bassa. That is exactly what we want to be doing. If you're ever going to download for me. Stop being awful. Why are we being awful? CD VBox. We're not going to use curl. We're going to use wget. Not for any good reason, just because I'm going to be obstinate if I have to download it this way. So, it's actually going to... Yeah. Diffs will help. I'm hoping that by the time we get all of this down, we'll also get a log. I can view their log, can't I? Because they make it available online. So if we get these two, we only need one time of that. So we have those. I don't want any of those things. I want to browse the source code. And you're going to tell me... Oh my god, it's so slow. View changes? How do I use this? I want to... How do I use this? All I want to do is see a log. Like, I want the SVN log. What do... Okay, here's a revision number. Oh, here we go. Okay. So... let's pull up a calendar here. Oh, we also lost my window. So the 15th was exactly 3 weeks ago. 1, 2, 3 weeks ago. So that means the 15th was 21 days. How do I get older than this? Oh. I feel like I'm looking at this through Tor. It's so slow. Why are they committing... Why is there built stuff in their repo like this? Like, why are there binaries here? Grumble, 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 grumble. Of course it's slow. Okay, so 3 weeks. That's 602. Wait, how do I get on the 5 branch? Crap. This is going to be hard, isn't it? Nope, what are we doing? Oh, cancel. Go away. I don't want to download it. I want to browse again. It's so slow. Okay. Can I see branches easy? There's only one branch. Thanks. So how do they keep track of different versions? Okay, so they have bug refs here. Yeah, we're just gonna cancel all of you. I don't know why you're being so terrible, Chrome. So we have, or is that a Qt bug ref? No, that's not a... Oh. No, their latest update was 21 days ago, which is actually what we wanted. Okay, so the Git one we can actually use for this, although these are not particularly... Oh, this is so hard to read. Wow, this is awful. So there are bug refs here, which means they have a bug tracker, don't they? Is it an internal-only bug tracker? It probably is an internal-only bug tracker, isn't it? Public SVN, I don't care about that. Community? Public bug tracker. Okay, no matches found. Okay. Sorry. Seeing stuff pop up like that is interesting. So 9241. Is this popping up timestamps? Awesome. This cannot possibly be correct. Do I think building something like Mayhem is feasible for the open source community to do? Yes. I don't know what the current status of Mayhem is. I know I've talked to the guys at For All Secure a number of times. I know that they definitely feel it is much better than anything public. Although I suspect that if people wanted to, taking a tool like Anger and making it roughly equivalent is within the scope of doable things. With that said, the guys behind Mayhem have spent, at this point, 5 years working on it, several of them almost full-time. They're putting a ton of work into it. But I think Anger is at least somewhat similar in what it's intended to do. And the only tricky part then, I'm assuming unleashing Mayhem on binary code, that's probably the... Was that the first thing they did where they threw it against the Debian repo? Yeah, Debian repo, wasn't it? Yeah. But yeah, I definitely think it's very doable. In fact, it's probably well within the scope of things people could realistically do. One thing that's important to note that I believe was the case for these is that these are largely... a huge number of their results are related to like command line parameters. At least one of the reports does, because you think we should move to more to automating this research. So one of the big issues that there is with trying to do like truly full automated bug finding is that it's really hard, namely because the hard part largely isn't driving interesting inputs. It's finding where to put interesting inputs. Like we still see with Like, we see things like AFL constantly finding bugs, not because AFL is doing something drastically different than what's been done for the past decade, but because it's very easy to use and it's very easy to hook up to just about anything you can find. So what people are doing are, with older fuzzers, it could take a day or two to try and get any sort of instrumentation working, trying to get a harness wrapped around it, things like that. AFL really changed things by being pretty easy to get working on just any target you wanted and then just shoving stuff into it and seeing what happened. I think it's a lot of the reason it's so successful is just because it's so user-friendly. I think Anger is probably the closest we'll see to a public mayhem. Although I know the For All Secure guys have at least talked about having a commercial offering. I don't know if it's gone anywhere or not, but the last time I talked to them, there was discussion that they wanted to make Mayhem commercially available. And similarly, what's it called? Microsoft Research has something similar that I apparently don't remember what it's called. Springfield? No, not even close. But yeah, there's a number of things that people have been doing that are available. This is all a very long way of saying, yes, automated bug finding is useful. However, the hard part is finding out where to look for bugs. And that's what we're doing now, is we're trying to figure out where we should be looking for bugs if we were to try and find new stuff. So, we're back over here. We got this. We had their... Oh, it is Springfield. Look at that. Ha! I am not crazy. Microsoft risk detection. Huh. Yeah, so this is Microsoft's thing that, like, you're able to give it binaries. It goes pew, 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 and runs the cybers on it, and it spits out and says, here are your bugs, go fix them. It's a thing. I don't know how public it is and everything, but it's a thing. People are doing it, and at least Microsoft Security and the guys at For All Secure feel it's something that commercial people will pay money for. We'll see if it works out. But back to what we were doing. Oops. Of course, that's probably the one. Oh, here we go. So this is ticket 9241, and if we go back over here, the reason we're looking at 9241 is because this fix talks about bugref 9241. I suspect that the patch here is not fixing something they just fixed, is not fixing a bug that was closed 7 years ago. What about this one? How do bug refs line up to something? That might help here. If I could get a bug ref to line up to something, maybe I can... So where we're at right now is we have source code, and actually, VirtualBox source. We have downloaded their source code. We have both 5.2.22, 5.2.22, and 5.2.24. Yep. We have both those to line up SVN commits and bugs. So once we have that, we need to figure out how to match them up, because if we can match them up, then we can actually do something useful. Because otherwise, so we have, so from this, we know there's a ton of bugs that got fixed. We know that almost all of these got fixed in 5.2.24. Actually, can we cheat here? Is this going to come up with anything? What is this? These are bin utils updates. Maria, what am I using for the checklist? The checklist here is Atom with the to-do plugin for it. Yes, John, the videos get pushed regularly. Check out the ZDI advisories. ZDI advisories, VirtualBox. Ha! This is actually probably where I should have started. I didn't realize they were this easy to find. Okay. Does this tell us anything? So this is CVE 2019-25-26, which tells us this vulnerability allows local attackers to execute arbitrary code on vulnerable installations of VirtualBox. An attacker must first... So if I have code execution in a guest, I can get code execution on the host. Awesome. The specific flaw exists within the CR server dispatch get active uniform method. The issue results from the lack of proper validation of... Awesome. This is exactly what we want. Which can result in an integer overflow beforehand. So this is a... So... here we go. This is convenient. So all of these came out at the same time. I wonder, is this list the exact same list as the ones from Oracle? Probably. But every single one of those requires a non-default checkbox for 3D acceleration. Okay, that's good to know. So we want to put that in our notes. Where did my notes get to? Oh, I don't have notes anymore. CD into VBox notes. VirtualBox notes. Lots of bugs in 3D acceleration, but 3D acceleration requires a non-default checkbox. Okay, that is good to know. And it is now in our stuff. So this is the 2500 one. Same thing, code and target, gets us code in the host. And this is the CR server mural visible region, which sounds like it's going to be the 3D rendering stuff. The issue results from a lack of proper validation of user-supplied data, which can result in integer overflow before allocating a buffer. Huh. It looks like a bunch of these are all basically the same bug that somebody found in... Like they found one example and then found 20 cases of it throughout the code. Speaking of which, that's actually something that comes up a lot when you're looking for bugs. If you're able to find a single concrete example of, in this case, The issue results from the lack of proper validation of this. And if we looked at this one, this text is exactly the same thing. Now, we're going to have to go through, we're going to take a look at these, and I don't know for sure if this is true or not, but my guess here, because both of these... oh, interesting. So they have different credits. My assumption here was that, there's one class here that there's some sort of some pattern that they use throughout the code, which my guess is that it's in the format of, I'm going to allocate 20 bytes for every of a certain size struct. Like, I say allocate, I guess, mural visible region is probably going to, so knowing 0 about what this is. The function says CR server mural visible region. Mural visible region. What this probably does is we're going to this is a function. It takes in some arguments to draw a mural, I guess, probably like a tile or something in a certain region. And if you give it certain coordinates, there's going to be an integer overflow because it's going to allocate 4 bytes per pixel or something. So if you try and render, trying to think of the numbers here, 1 billion pixels, it's going to integer overflow, you're going to allocate too few bytes, and then when you write into it, bad things happen. Maybe. Turns out that Niklas was entirely correct, and our clone failed hard. So if we do a bunzip on this one, we want a bunzip 2 because reasons. That's weird. Interesting. The chat in my preview pane is ahead of the chat in my chattable pane. Huh. Okay. So we have this pulled down. tar-xf. Let's get rid of this. xf. Okay. And now we're untarring this. You know what? I'm going to check this off as done. We know how to SVN now. The answer is we're not SVNing. But we have this. If we go back over to their bug tracker, is there a bug tracker for this? Interesting. Awesome. Their commits tell me almost nothing. This is going to be very painful. But I guess the good news is that almost all of the public VirtualBox bugs are from ZDI, and ZDI actually tells us where it is. This gives us at least a place to start. We just have to actually finish unzipping everything. Come on. Come on. This is so slow. don't know if tar will work, but with the BZs too or not. I know that I always do it manually because reasons. Because I seem to remember that under certain situations it works and in certain situations it doesn't, but ooh. Okay, so I want to look at 2018 2698. No results. Okay. No, 2018. This is why it's so convenient having somebody who's done a lot of this already in chat. So 2698. 2690. Do I have to click more? There's 2689. CV dash 2018-2698. Oh, okay. Huh. I wonder who reported this. Okay. Oh, here we go. And there's even a public exploit for it. How convenient. Which by public exploit, I assume that this may actually just be... wow, this is a lot of code. This is quite a bit longer than I thought it was going to be. Okay. So, Oracle were informed of vulnerabilities and released patches to address them. For more details, read that. Vulnerabilities found in the core graphics framework, VBVA, subcomponent, and affect all host operating systems. Provide an arbitrary read-write primitive in the Why is it not allowing me to zoom in? Okay, provide an arbitrary read-write primitive in the userland VirtualBox host process relative to the guest's VRAM buffer. The VGA device emulated by VirtualBox is associated with a certain amount of VRAM, which is mapped contiguously in both the host process running the VM and in guest kernel memory. Interesting. So we have the host process, which is running the VM, and the guest kernel memory, which actually backs the virtual memory. Part of it are used as general purpose shared memory segment for communication between the host and guest. Using this mechanism, the guest can issue certain commands to the host, for example, to implement mouse pointer integration and seamless Windows features. Am I able to get the VBox version from within? I don't know how you do it, but it's almost certainly possible. Typically, there's like a hypercall. So for most virtualization platforms, there's some sort of a hypercall you can make, or it'll be set in like CPU ID somehow that you're able to get it, or via the VBox VMM emulated device. See, very convenient. But I am not aware of a virtualization platform where you can't get the version when things are enabled. I think for some of them, if you can set it into a mode where it's harder to detect. But for the most part, most virtualization wants you to be able to know what you're running in so that you can take advantage of features. So like a good example is in VMware, I can like copy something here and then paste it into another VM if I wanted to. Actually, let's throw this in here real quick. CVE. I know I'm getting distracted here. oops, CVE 2018-2698. So that's what we're looking at right now. Being able to like copy and paste between VMs. In order to do that, though, a lot of the time the guest needs to know which version of the virtualization software we're running with so that it's able to actually use it properly. And that result is that in most cases, knowing what's going on is useful. The big case where it's not useful is when you're trying to do like malware analysis, because if you're doing malware analysis, you want the malware not to know that it's being virtualized, because a lot of the time malware is going to just like bail out and not do anything if it's being run in an emulated environment. So there's different things researchers do to make it harder to do that, but in general, people try and make sure that you're able to know where you're running. So back to reading this. So the VGA device emulated by, actually, let's work on our notes here some more. Wow, that is still untarring. Interesting. So that's not the right way I do that in Markdown, is it? Maybe it is. Except I want this split to be more like that. There we go. For anyone curious, what I'm doing here is I'm using the default Windows screen splitting stuff. I'm not doing anything fancy with that. It's actually built into Windows. If you hold down the Windows key, so I take a window, I hold down the Windows key, use directions and stuff, it by default splits it evenly in the middle, but you can actually resize them after the fact if you want to, and that's how I'm throwing these all around like this, so we can get a little bit better of an idea of like layouts in ways that make sense. So, vulnerabilities found in the core graphics framework. So this is important. I don't know what this is, but this matters. Provide an arbitrary read-write primitive in the userland VirtualBox host process relative to that. Parts of it are used as general purpose shared memory segment. Are used as a general purpose shared memory segment for communication between the host and guest. I don't know what this is, but this is probably also interesting. A host-guest shared memory interface. Using this mechanism, the guest can issue certain commands to the host, for example, to implement the mouse pointer integration and seamless Windows features. Okay, so that's going to be how the like mouse pointer gets back and forth between VMs, as well as, I didn't realize that VirtualBox has this feature, but being able to like drag windows in and out of the VM and have them around, but apparently it's a thing. The guest can also tell the host to copy data around inside the VRAM on its behalf via a subsystem called VDMA. Okay, out of bounds read-write in VDMA. Oh no. This is very important. So we got this. So in VVox VDMA command DBA BPB transfer, there's a struct that looks like this. Geez, this is very useful. So this is actually exactly the kind of thing that I want to find when I'm doing this. So here is somebody who's done a very detailed write-up of one of these bugs. It's possible the end result of these streams is going to be some of these sort of write-ups on more recent bugs, but we'll see. But anyway, we have this struct, which has some fields in it. When issuing a VDMA command of this type, which I guess lines up with that struct, a request object of this type resides in the host-to-guest shared memory interface. and is completely controlled by the guest. On the host, a pointer to the object is eventually passed to the following function inside the file. So we have source, VirtualBox devices, graphics, the device VGA VDMA. That's probably virtual DMA. So we have this function. VBox VDMA command exec BPB transfer. This is going to do stuff. Note 1 and 2. The guest controlled offsets, P transfer source off VRAM buff, and dest off VRAM buff are added to the VRAM address without any bounds checking. So we pull out this. We have a source and a dest that we have not verified. Okay. A mem copy is then performed with the guest controlled size. Wow. Is this really the bug? Like, there's just a straight up, I give it a offset and it just copies stuff around for me? Huh. That's a thing. Lewis, what shell? So I'm using Windows with WSL, although I don't actually have any shells up on the screen here. I've got Vim down here that I'm using to take notes, and I've got Atom over here for my checklist. But that's it. I don't have any open shells right now. So we have this VDMA present BLT. Issuing a VDMA command of type VBox DMA command. A request object of this type resides in the HGSMI heap and is completely controlled by the guest. On the host, a pointer to the object is eventually passed to the following function inside the file. Also in the same file. So we had this copy. On the host, a pointer to the object is eventually passed to the following function. Guest-controlled offsets PBLT and PBLT off dest and off source are added to the VRAM address without verification. Is this actually the same bug? I mean, it's the same thing, isn't it? Note the assert in note 2 is not active in production build, so we can reach the else if. I love these things so much. So there's an assert here that's going to, or there's an assert someplace that, yeah, here we go. There's an assert here that is asserting that subrex is a thing, but because asserts frequently get compiled out in release builds, this line does absolutely nothing. It's just a comment in release builds, which is a questionable decision, but it does make it very convenient for finding bugs. Like, there is a non-zero number of bugs that you can find by just searching for asserts and verifying, like, is the thing used again before it being checked? I don't know if there are any more like that in VirtualBox, but there are almost certainly plenty of bugs like that in source code. We then perform a mem copy between the computed addresses. We have, so basically there's two of these bugs that are effectively the exact same thing. We will modify VBox video kernel module to trigger the bug. The modified module will allow us to create a device dev VBox pwn, which can be used to send arbitrary VBox VA commands via its ioctl handler. How convenient. In this POC, we will use a 64-bit Ubuntu VM. First, we download the VBox guest editions. We mount it. We then upload the modified files to the home directory of the VM and rebuild the extensions with modified code. There should now be a new device called this. So we have this rules. We then we copy this into the source. We then run it. Interesting. Running it is going to this is going to rebuild it for us. That's interesting. We're going to do that. We reboot. We now have a device. I assume the rules are what set these permissions. We now create a Python script, which is going to do things. So 4.5 is the transfer primitive. 1 and 2 are those. We have a read offset size, read, write, and do stuff. So get VRAM size is going to build this struct. It's going to do things, and then we get stuff. Okay. If we run it on Linux host, we're going to be able to do things. Okay. The second read returns the header of the shared library mapped directly after the VRAM. Sorry, I'm a little, I just had stuff pop up on the other screen that I am trying to glance through real quick. Okay, things are bouncing around, but okay. We're going away here. Okay, back to where we were. The second read returns the header of the shared library. Of course, you might crash the VM if we hit unmapped memory, which makes sense. For demonstrating absolute read-write, we need the VRAM base address. This script will find it. In our case, the VRAM is 33 megs. The first argument is the PID of the host process. First argument is the PID of the host process. Okay. I'm confused. I don't understand this part. But okay. So we write this in, we'll crash it by writing data to an unmapped address. Make sure debugger is attached. Makes sense. That is indeed the way that I would try and exploit this. Well, figure out that it's exploitability. We then have the find VRAM. Finds the VRAM page on a Linux host by expecting. Ha! That's cute. So they're going to use procpid maps to figure out where we are. We then have these rules, which make our thingbaboober a something we can read and write to. So here's the actual change we make. So this is the VirtualBox video driver, the HGSMI initialization and helper functions. So we have this code right here. This is the full version of it, not the modifications. Hello, people. I assume something happened and that a number of new people joined. Given that there are, what's this, 4 people in the past few minutes that have just joined. So we conveniently, over here on the right, we have the list of things we're working on. And currently we're taking a look at CVE 2018-2698, which is one of NiklasB's VirtualBox bugs. And the idea is that we're reading through these to try, we're going to read through a number of these VirtualBox bugs to get an idea of what the attack surface looks like that's already been exploited. Once we have an idea about that, we're going to be able to look at what other attack surface there is, as well as kind of get an idea of some of the exploitability once we found some of these bugs. But those are definitely going to be some future work. So at this point, we're probably about halfway through the stream now, and we currently are at the point where we have source code downloaded and are reading through some bugs. So I very highly doubt we will get anywhere near writing the exploits today. So this is the full thing. It's a very long file, isn't it? I guess that explains why we're dealing with why this was so long. So one of the things we can do that, no, I don't need new car insurance. This is one of the more annoying things about having a cell phone in the US is that I don't actually know if other countries have as big of a problem with this as the US does, but I suspect that like probably 90% of the phone calls I get are some automated scammer trying to get me to extend my car warranty or to sell me back pain medication, or what's the other one I've been getting recently? There's something. Just a massive number of phone calls. Almost all of them are related to some sort of scammy stuff. And in this case, apparently my car warranty is going out of date and they want me to extend it. And that is never a thing I'm going to do, especially not when they're calling me from an area code that no one else ever will. So Lewis, I try and stream every Tuesday at about this time. It's between 3 and 6 p.m. Eastern. I did miss the past 2 weeks, but at least for the next several weeks, I don't have anything that should interfere with it. At least the plan is to be streaming. So, to answer your question, the plan is to stream every Tuesday at roughly this time. But where are we here? So what I want to find in here is, where are they actually using the ioctl? Kind of want to just diff this, don't I? So one of the things that I've had success with quite a long time ago when I was looking for, not in VirtualBox, but other virtualization platforms, is building something like this device driver and fuzzing over that. So I guess let's go back up here. Scroll, 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 scroll. When we're in this, so this lets us crash because in here, we're just going to take our ioctl and we're going to write into it. And we just write a struct into it. And in this case, so they've identified that the first int is going to be some transfer primitive, then a length, then some struct, offset payload. Yeah, then some struct. And one of the things that I have previously done to some level of success is actually just take that and jam it into a fuzzer and just fuzz this for a while. So it might be worth doing something like that. If we can identify several of these interfaces, which we should really do by going into this and figuring out how this was implemented. So if we can figure out how this was implemented, it might be worth building a couple of these to just jam into some of these different interfaces, because a lot of the way that VMs with the host and the guest communicating is there's basically just a region of memory that's mapped into both of them, they both watch it, and they're able to talk back and forth through that region of memory. This is a very flawed way of thinking about it, but you can kind of think about it as a like connection between the two. Being that it's mapped together, it's a little complicated, but okay. So we have a lot of chat. Why is my mouse sticking? Bloop, bloop. Anyway, where were we? So yeah, this is one bug. It's actually pretty good. It's a pretty good idea of how this is written. Why is my mouse being awful? I'm not sure if you can see that, but my mouse keeps hanging horizontally when I'm moving back and forth. So in my notes here, this is one of the like the HGSMI, which is one of these shared memory interfaces that they talk back and forth. Arbitrary read writes. Which reading is just the original. Yeah. This is, funnily enough, almost exactly what I would expect to see for talking with these. But anyway, there's that. So it's in, I don't know if I like calling it that. So it's not in the HGSMI. It uses that. This phone. VDMA commands allows for arbitrary read writes. That seems true-ish. So this is one. This has a surprisingly good write-up for it. That's actually really useful for us to be able to read. Yeah. What? Is this the bug we just read? Why? I don't understand scoring at all. Why is it considered a improper access control? That makes zero sense to me as far as classifying this in any useful way. Like, it's not like, it's an improper access control, but in the same way that being able to read and write arbitrary memory in any process is an improper access control. It seems silly to call it that, but okay. So Ivan, the reason I use Windows is because Windows and Bash is because, in my opinion, Windows, or the Ubuntu on Windows stuff, is actually probably the best Linux distribution currently out there for desktop use. The fact that Windows just automatically supports basically all hardware and does so very well makes it much, much easier to use. The downside is file I/O is slow and trash, as well as a lot of networking stuff just straight up doesn't work. But for most of the things I do, I've actually found the most comfortable environment to work in is a Windows bare metal with the WSL as my primary shell, and then a full Ubuntu VM as my, in case I need to do something that's more intensive. But yes, I will make the claim that Windows is currently the best Linux out there for desktops. I know there are plenty of people who would disagree with that, but at least for most of the things I want to do, I want a system that works primarily, and I can sometimes do Linuxy things on it. And it turns out Windows does a very, very good job of that right now. Oh my, I have so many messages. Oh yes, the second call was about trying to sell me a back brace. That is awesome and exactly what I need. Okay, so that's that bug. We will call that one done. At least looking through it. Is WSL IO performance not super annoying? Yeah, I'd say it's about 5 to 10 times slower. It's just that most of the load that I have typically is not IO bound at all. The only times it's particularly noticeable is if I'm doing something like unpacking a large tarball. Oh, this is the wrong shell. Unpacking a large tarball is the only time I really feel it being noticeable that the IO performance is really bad. Most of the like, if I'm writing code, it doesn't matter. The IO is basically what I need it to be. At least for me, opening Vim is quite fast. And I don't think I've done anything crazy. I guess the only thing that I've done with this is the entire system runs off a 1 terabyte SSD. Oh, yes, I have. I like to use my Vim without plugins, so it's very fast to open up. But yeah, for the most part, I don't do anything that hits the IO very much. For people who are curious, most of the WSL IO slowdowns is, as far as I can tell, on individual opens and closes. So, like writing lots of data to a file is relatively reasonable speed. It's that every single file open and file close takes basically an order of magnitude more time than it would on a bare metal Linux system. If you're opening 5 different files, that's not too bad. If you end up opening 1,000 files for some reason, now you're looking at a somewhat painful runtime. But for the stuff I do, I don't notice it at all. With X forwarding, even running some graphical stuff works reasonably well. I will say I do end up SSHing into a Ubuntu VM that I have an Ubuntu VM running in Hyper-V almost all the time that I will SSH into frequently for some things. If I'm doing something that I know is going to be very intensive like that, a lot of time I'll SSH into that and do it there. But I think about probably 75% of my workload I can do on the machine and not worry about it too much. So how am I going to set up the lab? We'll see. I suspect it's going to be, I'll have that Hyper-V VM that's running Ubuntu running VirtualBox inside of it, because I don't care about performance in this case. And we're going to just run stuff that way. It'll probably be Ubuntu. So Ubuntu in Ubuntu on Windows is probably the setup we're going to end up with for testing. So we've looked at one of these bugs. We've gone through it. So here's the question here. We currently know that there is this HGSMI base. Where is the ioctl code for this? Like, will the stream archive be available? Yes. The stream will go up automatically. However, I need to check a box to push it to be public. And that should happen within 24 hours of the stream ending. As long as nothing crazy happens, I just need to make a better thumbnail for it than the default YouTube ones. And then it will be public and you should be able to watch it. For anybody who's curious, at least generally the stream archives go up pretty quickly, with the exception of the last stream where I didn't realize it was non-public and then didn't look at my channel for almost 2 weeks. So the more you know. But yes, the archive should be available no later than this time tomorrow. So we have this, send caps info, don't care about this, report host area, don't care about this. Don't care about most of this. Don't care about this. Pwn request. Ah, this looks convenient. So pwn request brings in a type. Type 3 is a custom VBVA command. We then have a size, an offset, and some data. So if size is less than this, we're going to throw. So one thing to note here for people who have never written a kernel module before, this is a kernel module to start with, which means that you can't just print back and forth. They're going to use print k, which is basically printf, but it's going to log to dmessage, I believe, on most systems. And because we're doing ioctl stuff, there's probably some code, I guess, down here. There's code someplace in here to actually set this up as a device. And that's frequently the way that you'll interact with some of these breakouts, where you need root on the guest in order to set up these devices and talk directly to them. So something like this is pretty common, at least in my experience, when you're looking at these types of virtualization breakouts. So if the request type is 1, so that is the, so there were 2 types, the 1, 2, and 4, 5. I'm not sure where those numbers come from. Preparing VDMA command for reading that many bytes. So we have a header size. We allocate a buffer using their code to allocate a buffer. We mem set it to 41s, okay? Because we're good people here and we initialize our memory apparently. We're casting it to this. The F flags is 2. Are you? Come on. What is this, and why does search not work? What is this format? Okay, so we have a command. This is a VBox VDMA cbuff flag, buff follows DR. I guess it's some sort of flag that if we were to dig into the rest of the source code, it'd tell us something about it. I don't know what it means exactly. There's some more flags in there that we're gonna have to figure out later if we were to build this, but there's also a CB buff. I don't know what that is that we're setting to -1 or FFFF, one of the two. We then have a DMA command, which is we're getting past that header. The enum type is this. And are you... Ooh. Why are you so bad? Come on. So there's 1, 2. Okay. Well, that's unfortunate. I was hoping that we can take a look at this and figure out a little bit more about what's going on. Because one of the options here that might be worth putting together, if not on this stream, then maybe on a later one, is just writing a simple fuzzer for this. If it's simple enough, we can put together some code to actually just jam in some of these arbitrary objects. So we have a pixel format, which is like that. Wow, these are actually quite complicated. They're much more complicated than I was kind of expecting. Like if we're going to try and write a fuzzer for it, we're going to have to actually work at it rather than just jamming data in. That's good, I guess. Makes it less likely that somebody has already found all the bugs there. So we submit a buffer, we push it, we hand it over, and it, right? The HG, so we allocated it, P is that, and then we've set all this up in P. Do we do something with P here? Oh, yes, we submit P. Okay, that makes sense. We then free it, and then we're going to return it out, I assume. Okay, that makes sense. So we have that. We have another of these, which looks roughly the same. What's the big difference here? So I assume that this is going to accept. So this one is writing. GVRAM, right? 2 is writing. Where is it writing here? So we allocated it. Allocate it, we do stuff. We copy it in here. P plus header size. Header size is the sum total of all the headers, and we fill out the headers. Okay, that makes sense. 3 will send a custom command, which looks like what? Huh. Yeah, so if we wanted to, this code actually just straight up works if we wanted to just jam random structs in here. I assume that, so I don't know if Niklas actually wrote this particular implementation or somebody else did, but this type of code, like what's on the screen right now, is exactly what I would work with if I was looking for one of these bugs and trying to use it. Something like this is exactly how I would interact with it. So there's an ioctl where we specify this type 3. We're going to jam some data in there, and we just very simply, we've got a request in here. We have a size on it and some data, and we just straight up jam that data into one of these buffers. And when it comes to it, so what's a MAC? So there's the first 32 bytes are going to be something. Looks like we're not initializing those necessarily. Yeah, we're not initializing those for some reason. I guess I assume they must be initialized as part of this, I guess. And then we're just going to jam data into it. And similarly, if you send in a type 3, it lets you just shove all that data in and do whatever you want. Because these are, there's an enum type, which is doing something with BLTs, whatever BLT is. And then it's filling in all the struct. So if we wanted to, we could actually have type 3, use this type 3 to shove in data and build this entire struct on the Python side as opposed to here. Just depends on what we want to do. This makes it easier to work with some structs because we have it in C already, and generally it's easier to work with structs in C than in Python, but it depends on what you're actually trying to do. So where are we? I think we're about done with this bug. Like this was exactly what I was hoping to find. I was kind of hoping we'd find many of these, but this is what we want to find. Is we now know that there is this HGSMI guest to host command context or interface, which is the kind of thing we want to look for, because anything that listens on this. So if we come over here, did I close that? I closed that, didn't I? Was this the one that actually had a little bit of detail in it? No. No, wait, no, there's detail in here. I'm being dumb. So the actual bug is in this code right here. And if we look into it, we would probably see that there's some mechanism that attaches this function to handle these incoming DMAs. If you want, I can give you a link that will lead to most of the public write-ups. I think kind of working through it as I go is a good way to start. Having everything collected in one spot is super useful and would definitely speed up the research. But for a lot of these things, kind of working through having nothing and figuring things out is part of the difficulty. So I definitely appreciate the offer, but I think you're right that just figuring things out might be the better way to go. So if we go into this, we have this source code now, right? So VirtualBox source. Okay, there we go. Source VBox devices graphics. Source VBox devices graphics. So we have all these graphics devices, and in dev.vga.cpp, someplace VBox VD. Let's actually search for this whole thing. So this. Interesting. So they've significantly changed this. So for anybody who wasn't following that, I'm looking the current-ish source code for a bug that NiklasB found 2 years ago. Found and reported. I don't necessarily know when he found it, but it was reported 2 years ago by him. So what do we have here? I assume these are roughly similar. So the signature of this is that there's a VBox VDMA host. Are these still a thing? Oh, interesting. So the actual interface has been changed. So we have a VGA state, which has stuff. How do these get hooked up? Because presumably, I actually want a DMA. Oh, no, I want a DMA BPB. Okay, so these got moved into a dev VGA VDMA. There we go. The files just got moved around. Okay. Oh no. Okay, let's see if I'm going to sneeze again or not. Of course, now that I've said it, I'm not going to sneeze. That's how that always works, isn't it? So now we actually have all this code to validate it. So this gets hooked up There's a channel, there's a buffer, there's a number of bytes. So in theory, there should be a function in here. Are these hard-coded? 2774. They are actually hard-coded. That's not what I wanted to see. So if we were looking for similar bugs, what we see here is that there's a enum type that comes in over this interface. And then there's all of these functions that will end up trying to process it. Basically, this is how we would try and start looking for bugs. So looking at attack surface things here, here is an interface that we know is available to the guest because we know that somebody has found bugs here previously, and that this function right here is what processes that data. This is where it comes in, and then it's going to be handed off to one of these based off of what's coming in. So, for example, we may want to look at a VBox DMA command type Chromium command, which when the BPB transfer comes in, this does something with the P transfer. So interesting. So the VBox VDMA command actually pulls in the size for it. It looks like, I guess it's probably a macro to copy stuff around or something. Or it's probably a macro to tell what offset it is, because the header probably has additional information in it or something. So a P Chromium command. How do these differ? So this sets up some buffer. Assert that cbody is greater than that. Okay. We then have a VGA state, which is the current VGA state. We assert that we're supported, I guess. And then what is a command dr as opposed? So the P function crh. So this is going to actually process it. And presumably this is also something that gets set based off of some other values. So here's a question that we need to answer sooner or later. How much do we want to set up the source diving here? If we're going to be looking, if we were to be looking for bugs, what I would do here, and I guess it's probably worth doing, even though I'm not going to be looking for more bugs. Is we're going to set up C tags for this repo. Basically, so if you're not familiar with C tags are basically tag files that let a number of different programs, but the one that I use them with is Vim typically, and it lets me jump around in Vim files to figure out where things are being defined. So, for example, back over here, I want to know what this is defined as. I would be able to hit Control square brace, right square brace, and it would jump to where this was defined, so I could take a look at it. However, because I haven't generated a tags file yet, I can't do that. So that's what we're doing now, because we're going to spend at least a little time looking at this. It's worth noting, we're not looking at the current version. If we were being, at some point we would want to look at the current version. But I assume we're going to jump around a little bit, so it's a good idea to get them for this older version too. Let's go back over here, since we're waiting for this to run. Like I was talking about in the chat earlier, this is one of the cases where I feel the pain of WSL being slower for I/O. We're trying to read all of this source code and do things with it, and it's a very large source repo, so it's going to take quite a while to actually run through. On smaller stuff or on bare metal, this would be much quicker, but because I'm on WSL, this is probably going to take a minute or two. So LX41, I've not tried Source Trail. There's a ton of different options for source viewing. The one that I found most useful personally is just looking at it in Vim, mostly because I spend most of my time writing code in Vim, so it's the thing I'm most comfortable with when it comes to reading code too. I know that different people have very different opinions than me on that, but I spend most of my time in Vim with essentially no plugins, so it's become kind of second nature for me to jump around in Vim and use it for understanding code most of the time. I will definitely say it's not always a given, but it can be tricky, but it's a thing that is doable. Okay, so we have this. We find this function. So we're jumping back up to current bugs. So if we go find the CR server dispatch, we should see something new. So let's go find this thing. Come on. Okay. That's not how that's supposed to work at all. I am very, very confused right now. This obviously just is not working, apparently. So we will now wait for grep to go through all of this, which is doubly slow right now, because not only are we thrashing on the much higher latency for file opens, we're also doing it in parallel to making all the tags files. So now we twiddle our thumbs. So we have our tags file. I can at least do this from the source directory. Let's not be that dumb. We have our tags file, which has stuff. There we go. So this is in the shared OpenGL CR server lib get shaders. N is what? N is no recurse in ag? Of course it is. So ghosts. We had this discussion earlier in the stream, which is basically Windows works with hardware, whereas Linux typically doesn't. And WSL is good enough for most of the stuff I do. So I use Windows with WSL for almost everything I do across, I think, 4 different computers. That's my current setup for, just because it just works with hardware. The fact that I never have issues with hibernation or going to sleep and coming back out, and I can do things like easily use an external graphics card on my laptop, makes some of the downsides well worth it. Plus the fact that when I'm not doing, computery things that involve code, I can play video games on it are a little bit of upside. I don't play very many games, but having it as an option is useful. So we have this. So this is, actually, let's move around here a little bit. So we are currently looking at this CVE. Let's put this into our notes. So we don't know much about this thing. We know this right here. And that's it. So we're going to go in here. Line 57. Okay. So in this version, we could end up with problems because this is 22 and this was fixed in 24, correct? So this is 25, 26. 25, 26. And it was affected prior to 5.2.24. So 5.2.22 is vulnerable, 5.2.24 is not. Now, one of the things we could do here is we could diff these two files. If we, because we have both the 5.2, we have both the 5.2.22 and the 5.2.24 source code available. We can just diff these, but I think looking at just the function to see what somebody has identified as a bug is going to be useful for us to do here. So we have buff size that we check to make sure it's less than 32-bit int. We then allocate it plus some thing here. If it successfully returns something, we're going to do stuff. We're then going to do things here. Get active uniform. Interesting. So the claim here is that the issue results from the lack of proper allocation of users' applied data, which can result in an integer overflow before allocating a buffer. So the claim is that this can result in an integer overflow. How? So we have a buff size. We also have a size here. Where does size get used? So I can see how this becomes a very large negative number, but with the description that it results in an integer overflow before allocating a buffer. So if buff size was, 1 byte smaller than the wraparound, assuming that the argument to crcalloc is a signed int, I could see that resulting in it. But that seems... What's it going to do with does crcalloc do something silly like it assumes all negative numbers are actually 0? That would be awful. But I wouldn't be that surprised. So let's go with that assumption. Let's assume that crcalloc assumes that any negative numbers are 0, which means that because we checked buff size against int32 max over 2 and not buff size plus the size of this header being less than it, that is our issue. If that is true, then we should be able to come into here. We're going to bunzip except bunzip is still not a thing. Bunzip2 is a thing. We're going to extract this. It's still going slow because I suspect we are done tagging. We're done tagging. What that means is that we can find out. So cr calic is a that's not what I want at all. So occasionally the tags don't work. Because it was defined in two different places, the tags only record the one case. And I think there's a way to handle that, but I don't remember how to do it off the top of my head. So instead, we're going to do this the other way. And we're untarring. And this is going to take quite a long time again. So the hypothesis here, and my assumption is that if we look at 5.2.24, we'll see that this comparison is going to look something like size of cr get active t. It's going to look something like that. That. I think it's a safe-ish assumption. I'd be kind of surprised if it isn't, given the description of the bug, but we shall see. Yes, we're waiting. Hopefully this is the last time we have to wait like this. Usually it should be relatively quick, I think, but turns out this time, like we got this overhead because of the setup that I use. Because we're using WSL, we have this extra overhead. So I got a message on Twitter while we're waiting on this from who was this? N-R about S2E, that apparently this is, at least in their opinion, similar to Mayhem, but open source. It's a platform for writing tools that analyze the properties and behavior of software systems. At least their opinion is that because S2E uses both the is a hybrid of both static and dynamic execution, like their little thing shows, it's closer to how it does it. Oh, this is from one of the other CGC groups, Kojitsu. Yes. So, for people who weren't aware, CGC was 2 years ago? 2 years ago, 3 years ago, some number of years ago. It was a big DARPA thing. They got a whole bunch of people together to fight each other for some millions of dollar prize. I don't remember if it was like $1 million or something, but it had 2 commas. That's what's important here. And the end result was that the Mayhem ended up winning the competition. However, there were a total of 7 teams that competed, one of which looks like is open source, and you can actually use it. So S2E is apparently one of the solutions. Mechafish was the shellfish entry, which is also open source, and it used Anger for a lot of their stuff. It was a whole big like automated thing built, and I'm sure any of the shellfish people watching this will tell me I'm butchering it, but largely it used Anger and then magic, and things happened and it found bugs. So, yep, that's that. We have now untarred 424 source. Where are we here? Host services. Host services. Share OpenGL. CR. Oh, CD. CR server lib. Server lib. And then sorry for the beeping, it's just as annoying for me. And then if we go to line 61, we see, yep, that is in fact exactly what, is that exactly what I was expecting? So they check to make sure that it's greater than 0. Oh. So did they just not fix this? Okay. So the story here is that the issue results from the lack of proper validation of user-supplied data, which can result in an integer overflow before allocating a buffer. An attacker can leverage this vulnerability to escalate privileges and exec code in the context of the hypervisor. The original version of this was checking to make sure that bus size was less than an int32 max. And GL size I. Oh, right. This is the one I actually have tags for. Right. I assume that that's the case. So this is just an int. It is a signed int, so it could be negative. Yes, that makes sense. So if size is a very large number, it will end up making that to be a number. Interesting. What does happen if we pass a negative value to CR calc? It accepts an unsigned int. So if it's accepting an unsigned int, then this doesn't matter. Yep. So the short answer is that Niklas is entirely correct. It doesn't matter here. So what's basically happening here is that previously, if buff, so for example, bus size is, -5, and size of CR get active T is, 20. Then what's going to happen is buff size is, we're going to allocate a 15-byte buffer. And where does this get used? Where does plocal get used? We're going to write. So we're going to write various things into plocal. as part of this function. So it looks like get active. So get active uniform right here is it accepts as part of its arguments pointers to a length, a size, a type, and whatever that is. That's weird. Oh, that's the data right after it. Right, of course. So it's going to end up having things in here. And it's going to fill it out. And this then results in a buffer overflow. Yay! Makes sense. So this is this vul. It's interesting. Let's take a look at how this actually works, though. So we have this C server dispatch get uniform. This is the one that what? That's not how computers work. Am I being dumb here? We found 2 entries in this folder. There are 2 files that contain this string, which is the function name. One is the tags file, and one is the source file where it's defined. It's not anywhere else. Go, grip, go! Go, slow grip, grow. There's a tags file that you finally managed to open. Come on. Come on. So what we're looking for here is I want to find out, okay, how does this get called? Because with the bug that NiklasB pointed out, the CVE 2018-2698, that one, there was a function that for various hard-coded types would call different processing functions. So what we're looking for now is presumably there's something similar here that's going to call CR server dispatch get active uniform. And that we can back up a little bit. We should be able to see, okay, this function gets called by something that reads stuff off a bus or something. We just need to actually figure out where that is. One of the things that is possible here is that somehow this server dispatch API entry is actually a macro that gets expanded into something, but we'll see. Yeah, that's what I'm thinking. If nothing else turns it up, it's possible. Of course. Okay. I'm apparently doing this the hard way then. What the shit are you? What are you, and how do you get called? So I'm not trying to reinvent all of it. I'm trying to find just whatever the logical grouping of code is that contains this. I want to step out a little bit farther in how their abstraction works to see, well, there's this which has whatever a get active uniform is. There's also these 20. The call site is an auto-generated code. Awesome. This is not what I wanted to see. So what is that thing? Well, so there are all of these. I don't know what they are exactly, but it would seem that these are probably all accessed similarly. How many of these are there? Come on. Oh, how do I turn off coloring? I guess that... Let's try this again. Actually, what I really should do is just change my scroll back here. Come on. Now we have a scroll back that actually works. Come on. So it's all the stuff in tag files. But I want to see all of them. Come on. So let's take a look at that then. What does the Googles tell us about this function? So that's the C, that's R, it's the ZDI entry we just read. There's diffs for it. Interesting. So Google has very little to talk about for this. Okay. Why are you being so slow now? Also, why did that not work to actually give me a real scroll back? Properties, buffer size is 500. Not 50 lines. You should work for me properly now. Let's try this again. Come on. Actually, while we're at it, so 2018, Tokyo 2018, what all did they have there? So there's an iPhone X browser, iPhone X. Was Tokyo all mobile stuff? It might have been. Okay. Firefox with some Windows kernel thing. Marcus Gasoline, Safari with a iOS kernel bug. I am sorry for butchering your name if you're watching this. Safari with a sandbox escape. Oh. Two Oracle bugs. Tell me more about these. Why are you making this so difficult? Wow, they actually update their blog quite a lot. Scroll, 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 scroll. Scroll, 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 scroll. Because of course offset is in some random ass number, not something useful to me. Okay, I want the day one results because those didn't come up in Google for some reason. So this ended up having the so we have Fluorescence, who targets Safari. He then does Edge with a Windows kernel escalation privilege. Then we have NiklasB. Look at that picture. Who landed a VirtualBox 1. Demonstration qualified as a partial success as he used an out-of-bounds read and a time of check, time of use to still. Why was it only a partial success? Okay. Where's the other? But they said they acquired 2. Oh, 2. That makes sense. So there's an out-of-bounds read as well as a time of check, time of use bug that were part of this. If I Google server dispatch API entry, there's a 94 slide presentation. Well then. It's partial because for a full chain, I would have had to use an LPE inside of the guest. Oh, okay. That makes sense. Oh, look. Oh, there's a recon talk on how this works. How convenient. So this is going in my notes. Resources. That thing. Okay. How VirtualBox implements 3D acceleration. Chromium rendering command, the vulnerabilities, fixes, exploitation. Yay. Blah, 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 blah. VirtualBox provides hardware-based 3D acceleration. This allows guest machines to use the host machine's hardware to process 3D graphics. It uses guest editions. 3D acceleration must be manually enabled in the VM settings. Guest editions install a device driver named vbox guest.sys in the guest machine. On Windows guests, it can be found there. Port mapped IO to communicate with the host. Untrusted guest systems should not be allowed to use this. Okay. VirtualBox. Thank you. This graphic is very useful. It is based on Chromium, not the Google thing. Completely different and just a name collision. Awesome. Add support for a new protocol. Host to guest communication manager. Okay. This allows Chromium clients running in the guest machine to communicate with the Chromium server running on the host machine. We have stuff. We can talk to it. Of course, it's on the Windows side. It's a Windows guest stuff. So we open a handle to the device driver. Then we talk to it this way. We connect to it, we talk to it, we speak to it. There's a protocol here. Ooh, there's a protocol here. Definitions for input buffer types, available guest functions, and parameter count. Okay. So to call it, we would do something like, we have a client ID, we have a function we want to call, which is setPID. Okay. There's a param, which is okay. Not quite following exactly what they're trying to do there, but that's okay. There's a type, which is, it's a 64-bit process, I assume, doing things. And we have our current process ID. So this is basically setting the guest's PID to be whatever the guest's PID is. Okay, I buy that that's a thing that can be done. When the driver receives a iactl message call, it does the following. It copies our input buffer from the guest to the host, performs a call to host code. It copies back the results from the host to the guest. Okay, we open up the driver, we send a connect message, we send a call message, calling the set version function. We then make a call to set PID. So we set a version in PID. Afterwards, we can start sending other call messages. Okay. And then we have to disconnect. Although I assume that if we're exploiting it, disconnecting may not be necessary. Although I can definitely see things where we like end up with a dangling pointer or something. Like we're not going to... I can see cases where we have to connect, disconnect, connect again, and then somehow get useful data out of that. Chromium client sends a bunch of rendering commands, opcodes and data for those opcodes. The Chromium server interprets these opcodes and data and stores the result into a frame buffer. The content of the frame buffer is transmitted back to the client in the VM. Okay. Sequence can be performed by the Chromium client in different ways. Actually, before we get too far here, what was this thing called? This was called... Okay. So we have that. We also have this. So these are two different places. These are two different interfaces where guests can talk to the host, which is where we would be looking for bugs if we were looking for bugs. Two-step will send a message with the rendering commands and let the server interpret them, and send another message requesting a result. Okay, there's buffered stuff. Okay. Allocates a buffer that's not freed until a client sends a message to invoke the... Interesting. So I assume this, towards the end of this presentation, it ends up having some actual exploit code for a real bug. Handles the opcode and data sent by a client, generated by a Python script. Okay, so they have a Python script which is going to generate C code to dispatch Chromium opcodes. Okay. Just an API spec.txt. Please, sir, where is my API spec.txt? API spec.txt. Oh. Did I misspell that? Oh, lowercase s. Ah. Okay. Python scripts read this file and generate various C files. Name of the function, required, return a parameter, a vector, category, alias, a vector alias, a props. Wow, this is... Okay, so we have a new list, which will have stuff. So it has two parameters, a list, parameter list mode. List is a uint, mode is a enum. Zero or more of these lines may be present. Each line describes a function parameter. Two fields follow parameter name and the parameter type. Huh. So if we go down here, we should end up seeing, what was this function called again? CR server dispatch get active uniform. No, we won't see that. Maybe we won't say that. Begin bitmap color. We have a param vec, which has some stuff in it, apparently. We have some more color stuff, more color stuff, more color stuff, more color stuff. How is this so long? Okay, well, I can see why there are so many bugs in the 3D rendering code, given that there is just a massive amount of attack surface here. Like, this is a lot. Like, there's so many of these. There are over 1,000 functions that we can talk to over this interface. Has VirtualBox SVGA enabled by default? I don't have the slightest clue. I actually don't know what is and is not enabled by default. I'm basically just going off of recent CVEs to try and get an idea of what might be there. So we have this. There's so much code here. Dispatch Chromium opcodes to the corresponding OpenGL functions. We have this that unpacks it. We then end up with all these cases. Chromium, blah. So what was this actually called? CR server dispatch. Get active uniform. Okay, so this is apparently where it would get called. Yeah, okay, so that's that. The vulns. So here are two old vulns. Well, they're old now. When this was published, they were new. VBox server client write ends up calling default receive before calling unpack. Wait. It turns out that receive write back and receive write back are the implementation of Chromium's so-called network pointers. No, there's documentation for this. How nice. Are simply memory addresses that reside on another machine. The networking layer will then take care of writing the payload data to the specified addresses. That is indeed the right slide for when we're telling things about memory addresses on other machines. Okay. So we receive a readback. Okay. It's a write what where memory corruption primitive by design within the address of the hypervisor. Awesome. RB is controlled and wow. Okay. Then this is interesting. So here are just several bugs in the same vein. Okay. So this gives us at least an idea of where to start. And by where to start, I mean, let's go through these real quick. So there have been so far one. Okay. How do I handle this? So what I'm doing here is I copied everything in here. I basically want to do Nope. D2D, join these two together, delete this, join this. queue. Okay. So here are all of the ZDI bugs from 2019. So these were all in the most recent batch 3 weeks ago, I guess. So we have that. And I think what we're going to end up doing is just go through this in the probably next week, because at this point we've been going for about 2 hours and 45 minutes. And I think it's about time for me to be stopping. However, if you want to watch more of the people doing computery things, let's pull this up in a second. I believe that Josh Watson should be starting his stream in, I think it's about 10-15 minutes. My understanding is that he's working on trying to write binary ninja scripts to automatically reverse a obfuscated binary. He's been working on it for a couple weeks now, so if that's the kind of thing that you are interested in, he should be going live in, like I said, about 10-15 minutes. My understanding is that this is a recorded video for him. He's currently traveling, but still wanted to get a video out today for the stream. So I don't know how successful he is, but it's something to watch, and I definitely recommend taking a look at it if you are interested in the binary ninja type stuff. Other than that, I guess to recap what we did today, we got our source code in, both versions. We got some rough SVNing in, not great, but okay. And we went through in kind of decent detail NiklasB's bug from 2018, which was, and if we come in here, we can see that that was in the host-guest shared memory interface. And we started looking at this 2019 one, which is in the host-guest communication manager. We also have a list of many other bugs that are probably similar. It looks like almost all of these from 2019 were in this Chromium stuff, assuming that that's what the CR here stands for. So next week, we'll actually go through all of these and start taking a look at how they worked to get a good idea for what they looked like, write some notes about them. This one is going to be interesting. So let's call that one out in particular in my notes. This one is particularly interesting because that one's different. All the other ones are in Chromium. This is in this SVC get buffer. And it's an uninitialized memory disclosure. So presumably, however we access this thing, we request a buffer. It gives us a buffer. It does not initialize this buffer if it doesn't have stuff in it. So yeah, that's where we are right now. Next week, we'll go through these, get an idea of how they work. Depending on how things end up going, we'll probably work through several of these. We might end up the next step being getting our build environment set up, or not build, debugging environment set up. So actually try some of these. Like these integer overflow ones, quite possibly are going to be quite easy to exploit. So we'll take a look at how difficult it's going to be to try and land one of these and give it a try. I think it's about it for this week. If you have any questions, feel free to leave a comment. Otherwise, the recording of this should be up within the next 24 hours. It'll take a little while for YouTube to do their thing and save it and everything, but it should eventually go up. Hopefully not the 2 weeks it took the last stream to go up, but I think that I have that resolved by, manually checking it. Other than that, I will see everybody next week for the next round of these, where we actually dive into a whole bunch of new bugs. So thanks everybody for showing up, and I will see you all next week. Bye.
If we drift to